My name is Paul Taylor. I'm an ex-dentist, llama rancher, amateur embryologist, and now a successful grantee. We got interested in llamas, and that I have no explanation for how or why that happened. That phenomenon was just barely getting started, the breeding stock pyramid. We went out and bought 3 or 4 females and a male, partly so we could be a breeding stock operation and be able to improve the property and organize it for raising of llamas. We actually went to South America to find the animals that we were most interested in northern Argentina and northern Chile, along the Andes, in the high plains of the Andes. Because Argentina at the time had foot and mouth disease, the U.S. authorities would not let us bring those animals on into this country for 5 years. To get live animals into the U.S. From South America is hard on the animals, and we did lose some animals in quarantine. So we were hopeful of being able to bring and move genetics all around the world, move llama genetics all around the world in the form of frozen embryos. In the end, we basically had to develop that technology ourselves because it was quite different from the bovine embryo transfer. And over a period of about 2 years, we figured out what an early llama embryo looked like, figured out how to flush them non-surgically without hurting the animals, and eventually got a pregnancy, which was a big deal. Sally cried. After 7 or 8 years of trying to freeze llama embryos by conventional means, things that I'd been able to read about, I just decided it wasn't going to work. And I knew that they were full of liquid. I didn't know that it wasn't essential liquid, but it was obviously water-based, and I decided if I could deflate them, remove the water fluid from inside, I'd have a chance of being able to freeze them. Llama embryos were difficult to puncture. They couldn't be punctured by the standard technique, the compression technique. I realized I had to be able to hold a portion of the surface, to actually get a grip on a portion of the surface in order to be able to pass an injection pipette through. Finally, I decided that the only way left that I hadn't tested that really stood a good chance of working was to find some way to present the injection pipette from inside the holding pipette. As of this moment, we have the patent granted for the method or process embodied by the embryo cradle. The suck and puncture principle. That whole principle is patented. Just went to the NIH website and found a grant offering that seemed to fit, in fact, seemed to be right up our alley. Tools for Biomedical Research was the name of the grant we applied for. I picked up the phone and called the NIH Small Business Project. And it was Marianne Wu who picked up the phone, and she turned out to be very kind and led me through the process of applying for a grant. She didn't help me with it in any sense, except to encourage me and keep me from quitting. But she wasn't even a part of the institute that was offering this grant. So eventually I got switched to ORIP. If I had been braced for the slow, deliberate pace of the grants process, it would have been easier on me. Everything just takes so long to unfold, and it's 4 months between application deadlines, and then after the application, you don't really learn whether you've done an acceptable job for another 3 or 4 months. You get back comments from the peer review committee, study group they're called. You are allowed 2 submissions of the same grant. So the second one could be improved on the basis of information you get back from the comments of the study group. So I reapplied and got a better score, but still not an automatically fundable score, close to that threshold. And I thought it was game over, really. We were bracing ourselves to live on Social Security here, because I never paused on the research. We continued to fund it ourselves, and in fact spent our retirement fund on that before help arrived. Someone made the decision that the project should be funded and declared high priority. At that stage, that I was blown out of the water. Imagine thinking that this had failed and 2 or 3 months had gone by, had no further hope of getting funding. But NIH staff stepped in and decided to make the award and declare it high priority. And the high priority declaration made all the difference from then on. I don't remember what I changed, but it would have been additional data, and some of it pretty much of a knockout. The use of the tool on llama embryos, and then the use of the tool on bovine embryos, which was something that happened in between there. Just tried to respond to the summary statement, which is the document issued by the study group. We created a corporation and named it Gene Search with the intention of using it as the vehicle for moving llama and alpaca embryos internationally. That turned out to be an appropriate name eventually for a company that would be marketing a tool for biopsy of human embryos, biopsy and DNA analysis of any kind of mammalian embryo. We're on the edge of the wilderness, and we didn't want to turn the ranch into some kind of workshop or office, and we knew that we needed to hire some people for the making of glass parts, for the making of the plastic tips in preparation for commercialization. So that's where we'll make the prototypes for scientists around the world to test and evaluate and make suggestions on improvements. Congress wants us to hire people, ORIP wants us to hire people, and we need to hire people in order to get that, to live up to our obligations under the proposal we made.